Blindsight provides us with a case study of perception without awareness, one that may help us to understand something more about the function of perceptual awareness. Now, I'd like to start, if I may, by asking you to perform a very simple task. I will show you a dot, and I would like you please to point at the dot. Please point at the dot. Well done. Here comes another one. Please point at the dot. Well done. Why am I asking you to do this? Good question. Crazy idea. Well, we're interested in functions of perceptual awareness. That's our issue. Here's what we might think of as a very simple idea. Perceptual awareness enables control of action. That is one of its functions. So, for example, in this case, you might say to me, Steve, I can point at the dot because I'm visually aware of it. I can point at the dot because I'm visually aware of it. One of the functions of my visual awareness is to enable me to act on objects around me, such as, for example, by pointing to them. I think that's a natural and compelling idea. Certainly historically, it's one that has been quite influential. What happens though if we consider cases where there appears to be a deficit of perceptual awareness? Can subjects still perform such actions as pointing to an object, or are they rendered entirely unable to interact with objects? Excellent question. That's the question that we can attempt to answer by thinking about studies of blindsight. Start with the definition. Blindsight is the ability of patients with absolute clinically established visual field deficits. In other words, there is a region of the visual field in which they are clinically blind, but they nevertheless have, and the blindness is caused by occipital cortical damage. So we're not talking about damage to the retina or to the optical nerve, but rather to parts of the brain which are involved in visual processing. And these patients who are clinically blind in some area of their visual field nevertheless have the ability to detect, localize, and discriminate visual stimuli, despite, this is the interesting bit for us, being phenomenally visually unaware of them. Now, this definition is important, so I think you should hold on to it and come back to it. On the other hand, it's quite difficult to take in all at once. So the easy way to get a feel for what blindsight is to look at some of the experiments which have been used to establish its existence. Here are some of my favourites. This is from an experiment by Tony Marcel. And what you see here is schematic representation, not supposed to be accurate, of an area of the visual field which is unaffected. So here the subject is not clinically blind, and an area of the subject's visual field in which they are clinically blind. So this is the region in which blindsight occurs. What Marcel did was to present a word to the subject in the good part of the visual field and ask them to define it, while simultaneously presenting a potentially disambiguating word in the blind part of the visual field. Now, subjects told Marcel, gosh, I can't see any other word, I can just see bank. However, those subjects also, when asked to define bank, told Marcel about the financial institution. Whereas on another occasion, when a different word, river, was presented into the blind field, so providing a different disambiguation, those subjects now told Marcel, gave him a definition about the kind of bank that you find by a river bank, suggesting that although the subjects reported being entirely unaware of the disambiguating word in their blind field, nevertheless they had picked up on it and somehow it was influencing their actions. Now, I should say, as with many experimental findings, there are some caveats here. There are some caveats. So I don't think we should take Marcel's paper as a demonstration. Cowey notes that unfortunately eye movements were not controlled or measured, so we can't regard this as a clear demonstration. It does, however, provide a nice illustration of the kind of evidence that supports the existence of blindsight. That's what I want here, just some illustration. A more basic illustration involves the pointing task, which I showed to you right at the start of this experiment. A subject can be asked to point to a light source, and that light source can be presented either in their good part of their visual field or the bad part of the visual field. What we find in Blindsight is that subjects report being entirely unable to see light sources in their blind field. They're clinically blind in that area, so that's what you'd expect. But nevertheless, they're able to point to those light sources just as well as light sources in the good part of the visual field. How is this possible? Well, in a sense, it's no mystery at all. Blindsight involves damage to part of the brain, the back of the brain, called V1, which is involved in visual processing. But V1 is not the only area of the brain which is involved in visual processing. So although it may be the most important part of the visual cortex, it's by far from all of the visual cortex. So in a way, the surprise with Blindsight isn't that subjects are able to point and make use of things presented in their visual fields. The surprising thing about Blindsight really is that subjects are so disadvantaged by it that they are rendered clinically blind by its presence. This was particularly surprising because we know from well over a century of research that in dogs and monkeys, comparable damage to the brain has a rather limited effect on their visual activities. It does rob them of any sense of significance. So a monkey who's suffering from the counterpart of Blindsight presented with a carrot will not really be able to respond to it as a carrot, but they have no problem navigating their world and interacting with objects in a reasonably normal way. So why is this interesting for us? Well, Blindsight, as I'm stressing, is not really mysterious from a neurophysiological point of view. Or if there is a mystery, it's that so much impairment results. But from the subject's point of view, it's actually very mysterious because the subject is in a very strange position of being entirely convinced that she cannot see anything, and yet being told by the experimenter that she is successfully identifying the orientation, the direction of movement, the location, or some other feature of that object. It's almost as if you were to wake up one morning and to be told, look, you've got eyes in the back of your head. You've got eyes in the back of your head. And I think you would quite reasonably say, look, it's completely mad. But if then it turned out that you were repeatedly correct about events going on behind you, you would at some point have to reluctantly concede, I think, that you really do, in a sense, have eyes in the back of your head, even though that's something you're entirely unaware of. That would be kind of crazy, mysterious, baffling to you. Likewise, Blindsight, it's not baffling to a scientist looking at the brain, but it is baffling to a subject in the same way that discovering eyes in the back of your head would be. Now, I wanted to show you this brain picture just very briefly. So here's sorry, it's slightly blurred, that was my mistake, a picture of the intact brain and a picture of the blindsighted brain, just in case you want to check my simplified diagram. So this is from an authoritative source, and what it's showing you is that even if you knock out V1, there are plenty of other neural pathways to lots of areas involved in visual processing. So Blindsight shouldn't be mysterious from the point of view of the damage involved to the brain. Lots of visual processing is preserved. Okay, so what I've tried to do so far is to give you a sense of what Blindsight is by providing you with first a definition to go back to, and secondly, a very loose illustration of some of the research. But I can tell that many of you are saying, gosh, I can almost hear that here in the studio. I can tell that you're saying, Steve, give me some evidence. Give me some evidence. Of course you want some evidence. After all, you're rightly quite skeptical. That's good, very healthy. So here's what I think is quite a compelling piece of evidence. So this is an experiment from Weiskrantz and colleagues. It's an old one from 1995, a classic experiment. And what they did was to present objects which could either be horizontal or vertical in the subject's Blindsight part of the visual field. And then they asked the subject to report whether or not he was aware, this was a male subject, he was aware of the stimulus at all. And he was encouraged to set a very low bar for awareness. So he was told only to report that he wasn't aware of this when he had absolutely no sense at all of whether something was present or absent. Even the tiniest sort of sense that there might be something there, he was supposed to say yes. And the experimenters report that he was repeatedly asked about this and repeatedly confirmed that that's what he's doing. Now, what you notice here are two things. One is that the subject is not uniformly unaware of things in the blind field. When the luminance is high, this is a higher luminance, a lower luminance, and a very low luminance. When the luminance is sufficiently high, the subject actually is reporting awareness 80% of the time, and that's dropping off as the luminance decreases, but it doesn't go to zero. So the subject here is sometimes reporting awareness in the visual field. Now here's the really cool thing. This is a, I think, really ingenious experiment. What Weiskrantz and colleagues report is, how often is the subject correct about the orientation of the object, horizontal or vertical, when he was aware of the subject, of the object by his own report? And the answer is around about 80%. In every case, it's about 80% correct here. Luminance actually isn't making very much difference to the accuracy across time, but it is making a difference to awareness, or reports of awareness. We're being careful. Similarly, this is the line with the crosses attached to it. Weiskrantz and colleagues reported how often was the subject correct about orientation when he reported being unaware of the stimulus. What you can see here is that there's really no difference. The degree of correctness is high for orientation, and it's practically the same when the subject is reporting awareness as when the subject is reporting the absence of awareness. Why is this exciting? Well, what you can see is that subjects' reports of awareness change dramatically, even though the subject is being very careful about using a very stringent criterion of awareness. So this change in reported awareness is unlikely to be due to the subject's criterion of awareness changing. But although that criterion of awareness is changing, although the reports of awareness are changing, so plausibly the subject's awareness itself, accuracy in discriminating horizontal from vertical things is not changing at all. Furthermore, whether the subject reports being aware or not being aware seems to make no difference at all to the accuracy of the subject's performance in distinguishing the horizontal from the vertical. Fantastic. What is this telling us? It's an incredibly careful way of saying awareness is making no measurable difference to the subject's action. Awareness is making no measurable difference, none at all, to the subject's action. Brilliant. This is the key claim that researchers providing evidence of blindsight are establishing for us who are interested in functions of perceptual awareness. So earlier, when I asked you to do this exercise of pointing to the dot here, there it is, we were pursuing the question, what are the functions of perceptual awareness? And one thought was that you can point at the dot because you're visually aware of it. That's a natural thought which historically has been considered quite a compelling thought. It's an instance of a more general idea, which is that perceptual awareness has this function. It enables control of action. But now we've seen there's a compelling objection to that claim. And the objection is that blindsight reveals that sometimes variations in perceptual awareness of the dot make no measurable difference to your actions. That objection makes it seem that the simplest idea must be wrong. It's as if you were to tell me feathers are, one of the functions of feathers is that they enable flying, but I found again and again when you strip the feathers, the bird is still able to fly. Don't strip feathers. We're all very fond of birds, and we're not going to strip any feathers at all. We're not going to strip any feathers at all. But if you were to, and you found that the birds could still fly, you'd be like, well, I'm not absolutely convinced anymore that feathers have this function, they enable flying. I mean, it could turn out that that was wrong. It's not very straightforward here, but looks like a fairly compelling case. Certainly more research is needed. Similarly, this objection, it's not a knockdown objection, but it looks like a good objection. Take away the awareness via blindsight, you'd still have control of action. Very hard to hold on to the idea that your perceptual awareness enables you to control your action.